So we're again on number 6, we're in section 4.7. So right before 4.8, which we already did. We did a little out of order this time. And again, we just have a few problems on this page before we're done. So this problem, again, we're doing 6 and then we're doing 5. I think this is a good order because 6 is going to help us set us up for number 5. We're talking about a viewing angle. So it says we're standing in an art museum to view a picture. And the picture is 12 feet tall and the bottom of the picture is 2 feet above our eye level. So the angle that we're looking at is this angle right here. So kind of like from the bottom of the picture to the top of the picture. So from the bottom of the picture, like here at 2, all the way up to the top of the picture is the angle I'm looking at. Now, the problem with this is it's not a right angle. And we're in a section on trig, and trig is only right angle geometry, essentially. So in order for us to solve this with the tools that we have to use a right angle. The first part says, show that theta equals tangent of -1 of 14 over x minus tangent -1 of 2 over x. In order to show that, I need to draw 2 triangles from this picture. So the first triangle I'm going to draw from this picture is an itty bitty one right here. This little skinny triangle. That's not what I wanted. I want that backwards. There's Fisher. This is an itty bitty triangle. I'm X distance. This is me. This is the wall. I'm X feet away from that, and that's 2 feet up. So I've got an itty bitty triangle. The next triangle is not going to be from the base of the picture. It's going to be the entire big triangle I see in front of me right now. It's going to be this shape. And I'm going to do it just on top of it just for sake of my space. It's a little exaggerated, but it's not just from 12 feet. It's going to be 2 plus 12. It's the entire shape right there. So that's going to be 14 feet tall, essentially. I've got my little right angle because, again, I can't do anything unless there's a right angle. And I'm still standing X feet away from it. So this is where I'm standing, and that's where the wall is. Now, theta is just this angle right here. It's not the entire angle. It's minus the little sliver that's in the little tiny triangle. I'm going to use like a symbol you maybe haven't seen in math before, but if you've taken physics, you might have seen it. I'm going to use a lambda right here, which is kind of like a Y. So I just curve down and then loop up. Or you can just draw a Y if that makes you happy. But lambda is another Greek symbol that we use as angles sometimes. I'm going to call this little skinny guy lambda. And I'm going to call the big angle, it's not just theta, but it's theta plus my little skinny lambda. So that's that angle. This is this angle. I'm showing us that theta, the angle that we want, is this expression because in the first triangle, my big triangle, I've got this angle. Its tangent would be 14 over x. So when I write inverse tangent or tangent to the -1st of 14 over x, I'm talking about the angle of theta plus lambda. I'm talking about that big angle here, not the purple one that's theta, but all of it. And then I'm going to minus off the angle lambda where my tangent there is 2 over x. So when I'm talking about inverse tangent of 2 over x, I'm talking about this angle right here, lambda. This works out nicely because lambda minus lambda crosses out and I'm just left with theta. So theta equals theta, that's true. The whole reason I showed you those different angle measures is because we're going to use this formula right here. I'm using this equation that they gave us, tan to the -1st of 14 over x minus tangent to the -1st of 2 over x, and we're going to put that in the calculator in order to solve. This is what we're going to do on number 5. I didn't think we could come up with it on our own, so I thought it'd be nice to look at an example where they gave us the problem. We just had to prove why it worked. And now we're going to prove that the maximum value of theta is approximately 5.3 feet away from the picture. So we're going to graph this in our calculator. It does say to use degree mode, and we're just confirming that the maximum of this graph is going to be at 5.3. Okay, let's do that. I'm pulling my calculator up. I hope you guys have yours off to the side. I'm putting this equation into my y1. So I'm going to go to y1, and I'm going to do second tangent. So that's tan to the negative 1, 14 divided by x. And I'm going to say minus second tangent of 2 divided by x. Okay. So again, I'm just writing the equation they gave me. Anybody have any questions so far? What I'm going to do now is I'm going to go to my mode to make sure I'm in degree, because it did say viewing window is in degree mode. So it says degree. Okay, that's good. That's what I want. If it says radian, make sure you switch it to degree. And then I'm going to go to my window, and it tells me that my window is going to be 0 to 25 by 0 to 55. The first set of numbers goes with my x's, and the second set goes with my y's. So I want my x min to be 0 and my x max to be 25. I want my y min to be 0 and my y max to be 55. Now, I would have had no way of knowing that except they told it to me. So since they're going to tell it to me, cool, I'm going to take it. Anybody have questions so far? Okay, I'm going to press graph. And I know my calculator looks a little different than yours, but this is what I get. It's a weird shaped graph, but that doesn't matter to me. It's got a peak and then it goes down. And I want to prove that the maximum is at 5.3. So to prove the maximum is at 5.3, I'm going to second trace to find the maximum. Second trace number 4. I got to go left bound. I got to go right bound. And then my calculator just spits out the answer. Yours will say guess, but mine just spits out the answer. And it's going to say like the little P line. Again, my calculator looks different. Yours will just read it out pretty clearly. Mine says 5.29, which is my X value, and that's my max, which is approximately, oh, that's not what I wanted, 5.3 feet. So this problem, I wasn't necessarily solving anything, but I was confirming that that was my equation and then that was my answer. And we're going to do this exact same process on the problem above. This time they just didn't give us a picture, they didn't give us an equation, they didn't give us a window. So we have to find all those things. Any questions so far? Okay, let's move to the problem above it. This one, I don't know if I attempted at all to solve it with you guys. I tried to solve it with F, and then on Thursday, and I was like, no, I'm over this. I don't want to do it. But I'm glad that I waited because I do think it's better that we did 6 first. So I'm going to start by drawing a picture. It says the bottom of a 20-foot replay screen at Dodger Stadium is 45 feet above the playing field. So I'm going to draw a picture. Here's my viewing screen. And that's 20. And then I'm 45 feet above stadium. So that's 45. And here's the ground. Oh, there we go. Okay. Now, as the last one had, I have to have a triangle here. So I tried to draw mine a little 3D and it's not going to be good, but that's okay. So the bottom of my viewing angle is going to be from where I'm standing to the bottom of the screen. And then the top part of my angle is going to go from where I'm standing to the top part of the screen. So my angle, my theta, is going to be in here. Not this whole distance, that little tiny bit in there. And I want to know what my x is. How far away from the screen do I need to be to have the maximum angle? Let me draw my two triangles out again. I'm going to draw the little one and then I'm going to draw the whole one. So here's the little one, which isn't as little as the last one because it goes up 45 feet in out x. And I was using theta and lambda in the last problem. You don't even need to do that much because we know that my theta is this little tiny angle in there, not the entire thing. So we already know what it is. And so we don't have to, use other angle symbols to prove it. Now I'm going to do the big triangle. Ooh, such a bad triangle. I thought it was a rectangle. There we go. So I'm still x feet away, but this time it's 65 feet up. Just like we did the last one, we're going to do inverse tangent of the big triangle, and we're going to minus inverse tangent of the small triangle. So my theta, again, we're going to take the big triangle, big angle, and then minus off the small one, and we'll be left with the small part we want. So theta equals second tangent of the big triangle. If I'm coming from here, tangent is going to be 65 over x. So inverse tangent of 65 over x minus inverse tangent of 45 over x, because now I'm looking at this angle, the small one. Okay, any questions so far? Again, this is a harder problem than I would like to put on a test, but we're still going over it. So if you're like, I don't know if I could do this on my own, but I get why Miss White did what she did as she said it, then that's fine. You're in a fine place. Once I have this equation, just like the last time, just like the last problem, I'm going to plug this in for my y1. I'm going to change my window, and then I'm going to find the maximum, the distance from the wall at which the angle is the greatest. So I want to maximize what I have. So I'm going to do my maximum. Let's go into my y equals. We're going to clear that out. We're going to put second tan of 65 divided by x. Oh, not divided, minus second tan of 45 divided by x. I'll make this bigger again. So I just plugged my equation in. You can double check to make sure your mode didn't change. It doesn't change on you. It's still in degrees. And I am going to change my window. Now, I did this before teaching it today, so I kind of know what the window should be. But before this, I was just guessing and checking. There's kind of no rhyme or reason. I'm going to make my X max 100 because I think that will kind of clearly show us that the maximum. And I'm going to make my Y max, I think 20 should show it all, but we'll find out in a second. And again, there's no like rhyme or reason. I wasn't like, oh, I chose 100 because of the 65. No, I just am guessing. Guess, guess, guess. Okay, now I got my window. I'm going to go graph it. This does not have as extreme as a high, and it might just be the window that I chose. I could have chosen a window that made it more extreme, but you see there's a little baby hump like right here. And you can also see from the Y value. So I'm at like 8.6, and then my Y's are going up to like 9.4, 9.6, 9.9, 10 point something. And then 10.4, oh, they're still going up. And then now they start going down. So now I'm going 10.3, 10.1. So like right in here, I've got a maximum somewhere. So to find out exactly where my maximum is, I'm going to do my second trace max. We've been doing this all year. Second trace max. Left bound is over here somewhere. Sure, seems fine. Right bound. I try and go past where I think the, like way past where the middle is, because the calculator is smarter than me, so it'll find it pretty quick. Left bound, right bound guess, and then my guess was 54.0857. So I'm going to say 54.1. And that's not theta, that's my x. X is 54.1 feet away. So when we're standing 54.1 feet away from the base of that of the replay screen, we're going to have the biggest angle we can see. All right. Questions, thoughts, comments? Anything for me? Okay, we got a couple more on this page, and then we're going to do our extra practice. So go ahead and scroll up to 3. We actually will not need our calculators on this one. I'm going to get rid of mine. Go away, please. Thank you. And so 3 and 4 are the last problems in this packet we're going to solve. We are almost done with this whole page. Okay, now what's different about number 3 is that we're not just doing second or inverse trig functions. I'm not just doing tan to the -1 or sine to the -1. We're doing 2 trig functions. I'm doing sine of inverse tangent. This is what we call composition of functions. Do you remember back in unit 1 where I made us do like f of g of x or like g of f of x? Do you remember this notation? My kids 2 years ago kept calling it fog, f of g of x, but I don't think you guys liked that, so you didn't call it that. I don't know where they picked that up, but you did this back in algebra 2. I don't think you did in algebra 1, but it's not tough stuff. It just means we're putting one function into another function. And now that we've learned trig functions, we're going to do our composition of these trig functions. So I'm putting this inverse function into a normal trig function in order to solve. Now, the easiest way to do this is to look just at the inside. I'm going to solve what's on the inside, and then I'm going to take that to solve the outside. So I'm going to start here on the inside. I've got tan to the -1 of 0.1. Ooh, we're off to a tough start. 0.1, what does that even mean? Why is everything else as a fraction and that's as a decimal? Well, we can make that decimal a fraction. I know 0.1 is the same thing as a certain fraction. I know it's 1/10. But if I didn't know that, look what I can do. I can do 0.1 in the calculator, and then if you go to math, there's a function button at the top, or fraction button at the top. See how it says arrow fraction? I press that. So now it's going to take 0.1, which is a decimal, and make it into a fraction. And I get out 1/10. So even if you didn't remember or didn't know what that was or don't have a good understanding of fractions and decimals, you can put in your calculator and it spits it right out for you. Now, I want it as a decimal, or sorry, I want it as a fraction because I need to use a triangle here. It says find the exact value. That means that I have to do it by hand and not in the calculator, because the next step says check with the calculator. Not this step. This step says find the exact value. So we have to do an exact value. That means no decimals. That means no rounding. It means numbers and fractions and radicals. So I'm going to make a triangle. I think I'm going to make a triangle. There we go. If it says inverse tan of 0.1 or 1/10, then that means my angle, my theta, its ratio of its tangent of its opposite over adjacent is 1 over 10. So I'm going to go write 1 for opposite and 10 for adjacent. I'm going to need to find that third side because once I find it, I'm going to do sine of this triangle. So the third side I'm going to find by just doing Pythagorean theorem. So we've been doing this for days and days and days and days. 1 squared plus 10 squared equals x squared. 1 squared is 1, 10 squared is 100 equals x squared. 1 plus 100 is 101, and then square root. Root of 101 equals x. So square root of 101 is my hypotenuse. I just took inverse tan of 1 over 10 and I put it on a triangle. Now, I knew that this wasn't a unit circle problem, and I'm just going to scroll up for a second. The first 4 we did on when we first learned this were all unit circle problems because it said find the exact value, which means that we want to know exactly what it is. Not a guess, not a put in the calculator, exactly what it is. I don't think there's no 0.1 on my unit circle anywhere. There's no 1 over 10 on my unit circle anywhere. So that's why I drew my own triangle and then solved from here. Now I did my tangent of 0.1 and I now have theta. So now I'm going to do sine of this theta. I don't care what theta is. All I care about is the sine of it. And so the sine of that theta is going to be opposite over hypotenuse. So that's going to be 1 over root 101. You're welcome to rationalize that if you want. But I'm going to keep it as a fraction. This would be my best answer. However, in a second, we're going to plug it in the calculator. So while we're here thinking about this problem, let's make that a decimal just so it's going to be an easy check later on. So I'm plugging in 1 divided by radical 101 in my calculator, and I get 0.0995. So I'm going to check that in a second. Any questions so far? We got 3 more problems just like it. So if you're a little confused, stick on, hang out there. We're going to figure it out. Any clarifying thoughts right now? Okay, let's go to the next one. This one says secant of inverse sine of 2 over 3. Okay, I don't even have to care about secant right now. Let's deal with the inverse sine of 2 over 3. Again, draw my triangle. I know sine is opposite over hypotenuse. So theta's here, opposite hypotenuse. I've got 2 for my opposite and 3 for my hypotenuse. So let's plug that into my Pythagorean theorem to find my adjacent side. 2 squared plus x squared equals 3 squared. 2 squared is 4 plus x squared equals 3 squared, which is 9. Minus 4 from both sides, I get x squared equals 5, and then square root x equals radical 5. Any questions? Okay, we've got our shape, we've got our theta. And again, I don't care what my theta is. I found it. I found this triangle. So now I'm doing secant of this angle. We remember that secant is the same thing as 1 over cosine, or the reciprocal of cosine. And so that means secant is going to be hypotenuse over adjacent. We're flipping cosine. If cosine is adjacent over hypotenuse, we're going to flip it and do hypotenuse over adjacent. So my answer here is going to be hypotenuse over adjacent, or 3 over root 5. Again, I'm going to find my decimal because I'm going to need it later. And I get 1.3416. Again, all I've done in these shapes was I took the inside function to make a triangle. I took the two sides that they gave me to find the third side using Pythagorean theorem. And then now with my full triangle, I found whatever trig function was on the outside that they asked me to find. Anybody questions so far? Anybody questions so far? Okay. All right, let's do letter C. I've got tangent of cosecant to the negative first of 3/2. All right, cosecant. Let's think in our brains. Cosecant goes with 1/sine. And so if sine is opposite over hypotenuse, we have to flip it. So I've got hypotenuse over opposite. Draw our triangle. Everything, we're just following the same path. Here's my theta. Here's my opposite. There's my hypotenuse. And my hypotenuse is 3. And my opposite is 2. Now hold on, this feels really familiar. Let's play smarter, not harder. This is literally the same triangle we just did, right? My hypotenuse is 3. My opposite is 2. I just did this Pythagorean theorem. If you're welcome to do it again. I don't feel like doing it again because I literally just did all the work over here. I could copy and paste it. It would all be the same. And this missing side is going to be √5. Anybody complaints on that? Again, let's work smarter, not harder. There's no reason to do 17 Pythagorean theorems if I already just did this one. Okay, so I did my cosecant. Oh, that's not what I wanted to do. I did my cosecant by making this triangle, so that's done. Now I need to do tangent of my theta. We know tangent is opposite over adjacent. So in this case, I'm going to do 2/√5. That's my exact answer. Let's find what its decimal is because I'm going to need to plug that in a minute. 2 divided by √5, I get 0.8944. Okay. Any questions so far? I hope we're getting the hang of it. We got one more to do. And this last one is a negative, and we haven't had any negatives. I want to just like kind of pause and remind us that on Thursday, I told you these important things. I told you that inverse of sine is always in quadrants 1 and 4. Inverse of tangent is also in quadrants 1 and 4. And then inverse of cosine goes in quadrants 1 and 2. Now, everything we had just done was all positive, which is why we were all kind of hanging out in quadrant 1. I didn't necessarily put these on a coordinate plane, but they're all hanging out in quadrant 1. That's in quadrant 1. This one's in quadrant 1. I was kind of intentional about drawing my triangles this way. This one's quadrant 1. Now, technically, this one's going to go in quadrant 4. It's not going to mess up anything else because cosine in quadrant 4 is going to be positive, so it doesn't matter. But I'm just trying to play it, show you everything as right as I can think of it. So I'm going to draw this triangle in quadrant 4. And I'm going to remember that sine is opposite over hypotenuse. So I've got my opposite side of -1 and my hypotenuse of 5. And then my theta always goes in at the origin. Also, if you're not drawing these bow tie angles, make sure you are. Some people are still drawing funky angles like this on their shape, and that's not right at all. Make sure if you have a question on your angles, please talk to me. We do need to do Pythagorean theorem so we can find that missing side right there. So I'm going to do 1 squared plus x squared equals 5 squared. -1 squared plus x squared equals 5 squared. 1 plus x squared equals 25. And then x squared equals 24. So x equals root 24, but that's ugly. Let's simplify that. I think it's going to be 2 root 6. You may not have done that as fast as me, but if you don't know how I got that, make sure you talk to me later. If you're like question mark in your notes, please come talk to me. Okay, I had to find that missing side because I need to do cosine. And cosine of the angle is going to be adjacent over hypotenuse. So in our case, it's going to be 2 root 6 over 5. And I can do that in my calculator to find out what its exact decimal is. Two root 6 divided by 5 is 0.9798. All right, cool stuff.
Miss White, I have a quick question.
What's up?
I'm just confused on why that one's quadrant 4 and the other ones were quadrant 1.
Great question, Becca. The reason this one's quadrant 4 is because it's negative. And sine is only negative in quadrant 4 for the inverses. Now, if you drew it like it was in quadrant 1, but then labeled your opposite as -1, you would still get the same answer. So there's no, it's not as important as what we were just doing where it was like really important that you were in quadrant 3 or quadrant 2 or quadrant 4. This sine is the only thing that's going to be negative there. And so if you label your normal triangle with a -1, then you'll be fine.
Okay, thank you.
You're welcome. Good question. Any other questions? Okay, we're going to pull our calculators back out and we're going to check all of these answers now. We're going to check all of these answers. Some of them are going to be super basic. So like the very first one we're going to do, I can just plug that straight into the calculator. So letter A, I know I've got a ton of nonsense going on in all these pictures. Let me just highlight. I'll do like this, like red highlight is what we're talking about. I can press the buttons that say sine, cosine, and tangent. I do not have buttons that say cosecant or secant or cotangent. So if I have one of those, I'm gonna have to think for a second. But like letter 1, it just says sine of tangent to the -1st of 0.1. I'm literally gonna plug that in. I'm gonna press sine, I'm gonna press second tangent, I'm gonna type 0.1, I'm gonna close all my parentheses. That looks exactly like what I have highlighted in red. So I'm gonna press enter. 0.0995, is that what I got? Oh, yes, perfect. I did it. So we're gonna go down here. And I would maybe even make myself a note. I might even write exactly what I plugged in. Like I physically did sine of inverse tangent of 0.1 in the calculator and I got 0.0995, which is great. Now, the other ones, the next two, we're going to actually have to do a little bit of manipulating. There's no secant button in the calculator. So like if I go to letter B, it says secant of sine to the -1st of 2 over 3. There's no secant button for me to press. So let's do inverse sine of 2 over 3 first, and then we'll figure out what to do with secant. So I'm going to go down here and I'm going to physically write, okay, first I did sine to the -1st of 2 over 3. That's what I'm doing first in my calculator. Second sine of 2 divided by 3, and I got out 41.81. Now it wants me to do secant of that, but there's no secant button. Instead, remember that secant and cosine are flipped. They're in reciprocals of each other. So I can do 1 divided by cosine of this angle, and I should get the exact same thing. So flipping them, the same thing as 1 over cosine of this. So 1 divided by cosine. Remember, I can do second negative to get my answer just rewritten so I don't have to retype it in. And that gets me 1.34, 16. Is that what I got for letter B? Oh yeah, perfect. You're doing great. Okay, the first one was an easy plug and chug. This one we had to do it 2 steps, but that's okay. Any question with plugging in? Okay. Let's do C. Ooh, C says cosecant, so I got to do something different for that. Now, I cannot do like cosecant to the negative 1 of 3 over 2 is not the same thing as 1 over, 1 over sine of 3 over 2, or inverse sine of 3 over 2. As I was just saying with secant and cosine, they are the reciprocals. I told you that cosecant was hypotenuse over opposite. So I can just write that as sine by flipping the fraction, by flipping the actual ratio, not by flipping the trig function. I can write this as sine to the negative first of 2 over 3, and that's the same thing as cosecant of 3 over 2. I just flipped the sign here so that I flipped the fraction so that it was opposite over hypotenuse, which is what I want for sine. So I'm going to plug that in, and then I'm going to do tangent of that. So I'm going to do inverse sine of 2 over 3, and then I'm going to do tangent of whatever that answer is. Second sine, not normal sine, second sine, 2 divided by 3. And I'm going to do normal tangent of that answer. Oh, it was the exact same angle I did last time, but we should have known that because the 2 triangles were the exact same. So that worked out nicely. And I got 0.8944. Is that what I got before? Yes, we're doing good. Now, I highly suggest you're doing this with me, or you go back and watch this or try these all on your own, because what's going to be really frustrating is if you get to the test and you're like, I don't know how to plug anything in. I don't know how to do this. I don't know how to do that. That's a problem that we're going to have. So I highly suggest practicing this because that's such a silly skill to not know when you get to the actual test. All right, the last one's super simple because we're just going to straight plug this in. I have cosine of a sine to the negative first of negative 1 over 5. I can press a cosine button. I can press a sine button. So I'm just going to plug it right in. Cosine of second sine, negative 1 divided by 5, close parentheses, and I get 9798, which is exactly what I got up there, which is awesome. Okay, any questions so far? Okay, what we're gonna do is we're not officially done for today yet. We are done with this packet. So I am assigning 4.7 right now. It's due on Wednesday. I'll put a little Dropbox in later today. Remember, your 4.6 and 4.8 are due today. So 4.7 will be due Wednesday. All your homework will be turned in for this like section before the test. I want you to go to Schoology and get that worksheet I was just telling you about earlier, so that more 4.7 practice. We're going to just do a handful of these before you go today. Again, I told you there's an answer key on here. So if you need extra help with this, come in to see me and we'll do some problems like this together. Or if you just want to practice on your own, you can practice it and then check your answers back with the answer sheet. Not all of this we need. So if you're like, I've never seen this before, you can skip it. But like a lot of this is similar to what we've done in class and what I would expect you to know when we test on this eventually. So go ahead and download this. We're going to just do a handful of these. I do not need my calculator anymore. You can use your unit circle for this. The hard part here is there's just no like work you can show. You're just kind of using your unit circle. So we're going to try and do like this first column on the first side and then 3 on the back. And try and jump through those pretty quick. Anybody have any questions or need me to slow down? Okay. All right, so what you have are these problems. I told you, if you remember on Thursday, and then we reviewed just earlier today, sine is always in certain two quadrants. Cosine is always in two quadrants that we look at specially, and then tangent is in two quadrants. Remember that sine and tangent are in the same two quadrants, and that's quadrants 1 and 4. So I'm always looking in quadrants 1 and 4 when I'm doing inverse sine and inverse tangent. Cosine, though, is different. It's in the two that we think that should be in. It's in quadrants 1 and 2. It's in quadrants 1 and 2. So we don't care at all about quadrant 3, and we only care about quadrant 2 and inverse cosines. So all we're doing is we're going to go find these. So if it says inverse sine of 1/2, sine we know is my y value. And if it's inverse sine, I'm only looking in quadrants 1 and quadrants 4. So I'm going to go to my unit circle and I'm going to see, okay, where in quadrant 1 and 4 is there a positive 1/2 for my y? I believe the only place that is at 30 degrees or pi over 6. (30 degrees) or pi over 6. Anybody questions? I just searched and found. Okay. Similar for the next one. Now what's different here is this says arc cosine. I say that as like arc and then space and then cosine. It's the same thing as cosine to the negative first. So I also wanted to show you this paper because I want you to be comfortable seeing one or the other. So if you see arc anything, it just means that trig function raised to the negative first. So now I'm looking for my arc cosine or my inverse cosine of root 3 over 2. If it's cosine, it goes with my x value, and it also am only looking in quadrants 1 and 2. So I'm looking for in quadrants 1 and 2 where I have a positive root 3 over 2 as my x. And the only place that I have that is 30 or pi over 6. That's it. Questions, concerns? Okay, I'm going to keep rolling. The next one says arc sine, which I told you is the same thing as sine to the negative first. I also feel like that's a typo. It shouldn't have that much stuff. You can just erase the arc. I think that's messed up. Sine to the negative first or inverse sine of negative 1/2. Again, sine is my y, and I'm looking in quadrants 1 and 4 if I'm looking for my inverse of sine. Go find your negative 1/2 as your y, and I found that at 330 or 11 pi over 6. Similarly, the next one is another negative, but this time I'm looking at cosine, which means I'm not looking in quadrants 1 and 4. I'm looking in quadrants 1 and 2. And this is my x value. So let's go find our x. That's negative root 3 over 2. That's in my quadrants 1 or 2. My x is negative root 3 over 2. So sorry. At 150 or 5 pi over 6. The hard thing here is there's just not a lot of work. You don't even need to show this stuff. All I really want from you is the answer. So you don't have to show anything. But that being said, if you don't really know what I'm doing, then the little work I am doing probably isn't helpful either. So tomorrow and Wednesday are days 5 and 1. I'm in my classroom at 8. If anyone needs any help, come see me. The next 3 are quadrant angles, and I know that because they're zeros, ones, and negative ones. So the quadrant angles are ones and zeros and negative ones, all that fun stuff. The ones in between are like my 1/2s and my root 3s over 2s and my root 2s over 2s. So these are a little funny. So I'm going to go to sine, again, is still y, and I'm looking in quadrants 1 and 4 for where y is 0. And that's just right at the normal spot, right at 0, 0, or 1, 0, excuse me. So that's at 0 degrees or 0 radians. You could also say 360, but I think 0 is the cleanest answer. 360 is the exact same thing. So I wouldn't mark you off, but you'd only have to use just one of them. Next, I'm still looking at inverse sine, which is still my y, and it's still in quadrants 1 and 4. Now I'm just looking for a y of 1. And I see that at 90, or pi over 2. And then the last one's another inverse sine. It's another arc sine. It's another y. It's another one in quadrants 1 or 4. And now I'm just looking for -1. Where is y -1 in quadrants 1 and 4? And this time it's at 270, or 3 pi over 2. Okay. I got a couple more I want to show you. Anybody have any questions so far? We got a ton of other practice problems like this if you want to try those on your own or with me another time. I think we're just going to do 21 and 24 before we leave today. This you can use the exact same thing we were doing before with the little triangle, or we can use our unit circle. So this says inverse sine of 1/2. Well, again, we're still looking in quadrants 1 and quadrants 4, and we're looking for where y is 1/2. Well, that y is 1/2 at 60 degrees, or pi over 3. So I'm going to go to do cosine at 60. The inside got me the angle of 60 degrees. So now I'm doing cosine of that, which is just the x value at the point that I'm at. It's the x value of the angle I'm sitting at. And that's, oh shoot, I did that wrong, didn't I? Ooh, reverse, reverse. I hope I did that right last period. Sine is y. I don't know what I was thinking. And y is 1/2 at 30. No, that would have been bad. And cosine, or x at 30, is going to be √3 over 2. Now, if you were like, I don't really like this unit circle stuff, you could draw a triangle. Pretend that's a triangle. And my theta is here. Sine is opposite over hypotenuse, or 1 over 2. And then you could just find the missing side and then do my adjacent over hypotenuse. Like a little spoiler, this is going to be √3 when you do Pythagorean theorem. So it all works out the same, but if that makes better sense in your brain, do it that way. I want to just push and do 24 really quick. The reason is it's flipped. So normally we're doing the last 5 problems we've done the inverse trig function, and then we've done a normal trig function to get out a ratio. This next problem I'm flipping, and I'm giving you a normal trig function, and then we're going to do the inverse of that. So my answer here is going to be an angle, because I'm doing the inverse trig function, and when you do the inverse, you get out an angle. This is, again, pretty simple if we just look at our unit circle. So if I'm doing sine of pi over 6, let's go find pi over 6 in our unit circle. That's 30 degrees, and so sine, or y, at 30 degrees is 1/2. So I'm going to do inverse cosine of 1/2. And that just means now I want to know what angle has an x value of 1/2, and that is 60. Or if you want to think about it in radians, it's pi over 3. So you can go either direction. Now we've done one example either way. Okay. All right. Sorry I used the whole time up to when we would normally be doing the cleaning bell, but I wanted to get through that. Anybody have any questions before I stop sharing? Okay. If you have any general questions for me, hang on. If not, have a good day. I do see you tomorrow. Yeah, have a good day.
Miss
Thank
White,
you.